Hello students, welcome back. So in the previous part we have learnt about the basics of GP. In this part we are going to discuss about the two very important concepts, which are some highlights and the geometric mean. So let us have a look at both these topics. So let us have a look at some important highlights of GP as we saw in case of AP. The concepts in the GP are quite similar to the AP, the only difference being that there we were adding the terms, here we are multiplying the terms. So everything can be correlated using the similar concept. So let us have a look at one by one. So for first point, if you see that each term of the GP is multiplied or divided by a non-zero, again note a term non-zero, fixed constant, then the resulting sequence is again a GP. So what do I mean by here? So let us take a GP here, 3, 6, 12. So this is a GP. Now you can easily figure out that this is a GP having A is equal to 3 and R is equal to 2. The R is known as the common ratio. So if each term is multiplied and divided, remember in the AP we had all the 4 operations, but in this case we are having only 2 operations, that is multiplication and division. So suppose if I multiply each term by say 2, so my resulting sequence will be 6, 12, 24, and this will be 48, 96. So again you can see the only thing which has changed is A, otherwise ratio is again 2. So in case of AP, when we were adding or subtracting, the things were same. In case of GP, when we are multiplying, because in AP we were adding and subtracting, that's why it was remaining constant. In GP we are multiplying already a constant, so if we multiply another constant to every term, so basically we can take that common out and resulting series will be the GP with the same ratio. So this point is clear. Now instead of subtraction and addition, we are saying that if each term of GP is raised to the power k. So what I am saying is that if I instead of adding subtracting, there in case of AP we are taking a thing raised to the power. So if we raise to the power, what do I mean by raise to the power? Suppose I square every term. So this will be 3 square, 6 square, 12 square, 24 square. So let us limit to 4 terms only. So initial we can take this 4 as the GP. Now resulting sequence will be 4, 9, this will be 36, 9 into 4, and this will be 144, this will be 576. Now can you see both A is 9 here, and what is R? This is 4 times, this is again 4 times, this is again 4 times. Now when we are doing raised to the power, then the ratio is again raised to the power, that means we have squared, so ratio has become 2 square, that is equal to 4. So interesting thing, in case of AP, addition subtraction has no effect on difference. Multiplication and dividing were making it proportionate. In case of GP, only multiplication and division, they are having no effect. But when we are doing the raise to the power, although the resulting sequence is in GP, but the ratio has changed. Now similar concept to the AP, that if we are to take 3 terms in a GP, so they should be like this. Why? Because as I told, in case of AP the addition was giving us 3A. In this case the product will give us A cube. So remember that we will be given 2-3 relations. From one relation if we can find directly A, so in other relations by substituting this we can easily determine the R. So what is the trick here? If there are odd terms, the central term would be A, as compared to that AP, same thing. So now we are having even terms, we can distribute equal on both sides. Suppose if we are having 5 terms, so I'll take AR square, and corresponding to this I'll take 1 A by R and 1 A by R square. So when I multiply, these will get cancelled. Again, if we take 4 terms, so in 4 terms, again I'll explain using same thing. So if I take like this, so if I take 4th term, so it will be creating an imbalance. So I'll delete this, and like we did in the AP, we will be following this. So in this case, in that case, D became 2D in case of uh, even terms. Here in GP it will become R square instead of R. Okay, R will become R square. So now if you take the next term, it will be AR cube. Before that it will be A by R cube. So in general, this is the formula. So how we can remember? Don't take the central term. Take one before, one after. Now we know the ratio between these two. Accordingly, we can subsequently find the terms on the both sides. So that the ultimate aim is here is that when we are given a product relation, so the terms will get cancelled and only A will be left, and we will be able to determine that. In case of AP, addition would have given us the A, and we would have calculated the D from the other relation. Now this is again true if you look at the GP, AR square, AR cube, AR4. Let us consider 4 terms only. So if you take that this multiplied by this, basically A is common in everything. So what I can, for convenience, we can take this thing. So now if you clearly observe, I missed one term here clearly. So this will be AR and this will be R here. So when you multiply the extreme two ends, so this will be equal to this thing, and if the terms are odd, it will be equal to the middle term square. And if the terms are even like this, then it will be the product of two middle terms. In this case, we will pair this with this will go with this, and you can see when we are multiplying, the powers, they are remaining same. So this is again very easy, as one from the beginning, one from the last, second from the beginning, second from the last. The similar concept this is again very easy, the same concept, one from the last, one from the beginning, and second from the last, second from the beginning. So similar concept we are used here in the GP. So I guess GP was just a revision of AP, with just the difference that in that we were adding and subtracting. So let us have a look at the next topic, which is again very important, geometric mean. So in this remember AP, if we take a geometric mean, the 3 terms will be in AP. The similar concept is that when we take the geometric mean of 2 numbers, and when we write the geometric mean in between, if suppose B is the geometric mean, so clearly this will form a GP. So clearly from this, what do we require? Clearly B should be equal to AR and C should be equal to BR. Means we are constantly, that is equal to AR, we are constantly multiplying it by R. So from this, if we observe carefully, AC will be equal to AR whole square. So this will be B square. So B will be equal to root of AC. B will be equal to, so this is what is written here. So geometric means is like we did in the AP, what we were doing? We were doing the addition, and when we were taking the 2 numbers, we were taking the average. In geometric mean, in GP, what we do? We multiply with a constant. So when we are having 2 terms and want to find the GP, what we will do? Multiply 2 terms and raise to per half. In this we were dividing by half. In this it will be raised to per half. So it can be correlated that since we are multiplying the terms, we are taking this power, and in the case of addition, we are successively adding the terms, so we are here dividing it by 2. So let us have a look at the very important thing, inserting n geometric means. We will derive it using the similar concept which we did in the AP. So if we take A, and if I denote n geometric means, like this, and b will be here last term. So clearly corollary to the AP, it will have n plus 2 terms. So again I can write b is equal to a into r n plus 2 minus 1. So this will be a r n plus 1. So b, if I write r here, so it will be b by a 1 by n plus 1. Remember in AP it was coming out to be b minus a 1 by n plus 1. There it was dividing, here it is raised to the power. There we add the terms, so b minus a, here we are multiplying, so we are dividing in the final. So this is the, so if we are inserting one GM between two numbers, so clearly you will put this as 1 by 2. So now if first number is a, so what will be the second number? A into b by a. So this will be equal to ab raised to power half. That is what we have derived here. So next term will, if you further multiply it by this term, it will become ab raised to power half into b by half. So as you can see, this will cancel with this and b raised to power half will become b. So we have derived the same thing. Similarly, if we are inserting n geometric means, we can consequently find this g1 by multiplying a with this r. So remember this r for this. So you multiply a with this, you will get first geometric mean. You multiply first geometric mean with this, or what you can do, so you can simply put the value of the that geometric mean. You can apply this formula, a raised to power n minus 1. So if you are finding this is third term actually, so this will be ar square. So r is known and you can square this thing. So basically this number will get increased 2, 3, 4 and so on, depending on which geometric mean you are looking at. Okay, so let's solve some questions related to this. In geometric progression, we will see that some series, they are not directly geometric progressions, but they can be made. So this is the perfect example for that. In AP, we don't have any concept like that. So if a sequence is in AP, then it is always in AP. But some sequences related to GP, they are convertible to GP. So clearly here we can see that 3 by 19 plus, so although this is going in GP, but the numerator term is quite disturbing. So first of all, we can clearly see that we can take common 3. So this is 1 by 19 plus 11 by 19 square plus 111 by 19 cube. So it will go on. So now if I further reduce this, so how to solve terms like this? So basically the aim behind this is that if I do the first step, it will be very clear. If I take 9 common, 1 by 9 common out of everything, so I'll multiply it everything by 9. So now what was the purpose of using this? So now we can make two GPs. In one, this will be 10 minus, so 9 we can write 10 minus 1. This we can write 10 square minus 1. This we can write 10 cube minus 1. So all this 1 will get separated, and you can clearly see that one GP will be like this, 10 by 19, 10 by 19 whole square. So you can find the sum using the appropriate formula which I have given in the earlier also. So since this is going to infinite, so we will use that formula a upon 1 minus r. So a here is 10 by 19 and ratio is again the same. So 1 you will get by this. What about this? So this will simply, if you take minus common out here, 1 by 19 plus 1 by 19 square plus 1 by 19 cube. So I hope you can do this. Now this, so what was the purpose of this? So we cannot resolve this as the GP. So this kind of, I specially brought this kind of sum so that we can cover this part. This is not a theoretical thing. This is just, this can be just explained by using the example only. So if you would have taken this, so this would have been 1, 10 plus 1, again 100 plus 11. So now, although we are getting this okay, but this is going nowhere. This is again creating. So again you will have next term will be 1000 plus 111. So again you end up in getting the same sequence. So you will never end this with this. So that's why we have taken n common out here, so as to make this term, this series in geometric progression. So we have concluded with the geometric progression, which is the second major part of our whole topic. In this, we saw that under which conditions a GP remains a GP, how to take the terms of GP in a given situation, and we also came to learn a very important topic, that was geometric mean.